In this video, we are talking about alternate interior and alternate exterior angles. Before we start that, just some basic vocabulary of what interior versus exterior means and what alternate means when we're talking about angles. So interior angles are inside the parallel lines. If you think of the parallel lines and the transversal as a sandwich with a toothpick through it, the interior angles would be the inside of your sandwich. So interior angles are all of these. Now exterior angles are outside, meaning above the top line or below the bottom line, and those would be outside of the sandwich. Alternate angles are just any two angles that are on opposite sides of the transversal. So if we have an angle pair that is here and here, those would be alternate because one's on the left of the transversal and one's on the right. On the other hand, you could have alternate angles here and here because they are still on opposite sides of the transversal. Right now, alternate interior specifically, we're putting those two things together. Alternate interior angles are pairs that are inside the parallel lines on opposite sides of the transversal. So what that would look like is either here and here. That would be one pair. Okay, so those two would be an alternate interior pair, or here and here. That would be the other alternate interior pair. Alternate exterior angles are on the outside of the parallel lines and opposite sides of the transversal. So if we have this angle, the alternate exterior to it would be down here. So that's an alternate exterior pair, as well as here and here. Okay, now each pair that we've listed here is a set of congruent angles. So alternate interior angles are congruent. So if this is angle A and angle B, angle A is congruent to angle B. Then if we have C and D, angle C is congruent to angle D. Right, likewise on the alternate exterior angles. Alternate exterior angles are also congruent. So if we have angle G and angle F, they would be congruent. So angle G is congruent to angle F. And if we have J and K, angle J would be congruent to angle K. Now, all of these can be proven using vertical angles and corresponding angles. So just real quickly, I want to run through why these are congruent. So remember we talked about, I'll just use angle A and B as an example. So A, that would be corresponding to this angle here. And that is vertical to B. So using corresponding angles, A to this angle here, that would also be the same as this vertical angle. Right, and then to prove that alternate exterior angles are congruent, the same thing applies. If we take angle G and we slide it down to its corresponding angle, they would be congruent, which is also congruent to this vertical angle F. Now let's look at some examples. Okay, number one, if the measure of angle A is 30 degrees, so I'm going to write that down, what is the measure of angle B? Right, well, we can use a couple of different theorems, but you could also use your alternate interior and exterior angles. So if angle A is 30 degrees, then this angle here, I'm going to use 3 marks, that would be whatever 30 plus this number would have to be 180. So this would have to be 150 degrees. So if that's 150 degrees, this is an alternate interior angle to angle B. Those would be congruent. So angle B would have to be 150 degrees. All right, number 2, find the measure of angle X. Again, these are alternate interior angles, so they are congruent. So X is 100 degrees. Okay, number 3, what is the relationship between angle 1 and angle 2? Right, so angle 1 is above the top line. Angle 2 is below the bottom line, so they're definitely exterior. Angle 1 is on the left, angle 2 is on the right of the transversal, so these are alternate exterior angles. And we can abbreviate that for short. Okay, and number 4, here we have a little bit different notation that I wanted to show you. We have that line, anytime you see that symbol above 2 letters, that means line RS, so that would be this line here, is parallel to line TU, so that would be this line. So those are parallel. That's just in place of the markings. So if you saw the markings with the arrows, then you wouldn't necessarily need to see that written out. All right, so now we have measure of angle 6 is 4x plus 2. So I'm going to write that here. And the measure of angle 4 is 3x plus 27. Okay, well these two angles, angle 6 and angle 4, they are alternate exterior, so they are congruent. So they equal each other. So I'm going to set them equal to one another to start. And we want to know what is the measure of angle 3. So that's what we're looking for. Well, if I know x, I can plug x in and find the measure of that bottom angle. And those two are going to add up to be 100. So if I know x, I can plug in whatever x is, and this angle plus this angle add up to make that straight line of 180 degrees. So first we need to find x. So that's going to be step 1. All right, so let's move the 3x by subtracting it. That gives us 1x, or just x, plus 2 equals 27. And subtract 2 on both sides. So x is 25. Okay, but we're not done. If x is 25, what is the measure of that angle? So just using a calculator, or if you wanted to do it in your head, just make sure to check behind yourself. 3 times 25 is 75, plus 27 would be 102. So if this angle is 102 degrees, what would we have to add to it to get to 180? So step 2 is going to be subtracting 180 minus 102, which would be 78 degrees. So x is 78 degrees. All right, and example 5. Okay, this one incorporates a little more vocabulary and some more of those theorems that we've talked about. What are the measures of angle 1, angle 2, and angle 3, and explain how each measure can be determined. So we already know that one of those measures is 81. So angle 1 is how much? Well, if this is 81, then the next angle beside it forms that straight line, right? So this angle plus this one makes a straight line. That's 180 degrees. So 180 minus 81 is going to give us 99 degrees. So angle 1 is 99 degrees because they form a linear pair. That's the only way to get that one. You could also say supplementary. Okay, now let's find angle 2. Okay, well there's two things that we can use now because we know that angle 1 is 99 degrees. Okay, so we can use linear pair again, or we could use vertical angles because angle 2 is vertical to angle 81. All right, well, angle 2 we know is going to be 81 degrees by vertical angles, or you could also use linear pair or supplementary again here. All right, and let's see, angle 3. All right, angle 3, we can use angle 2 to get us there. So again, we said that this one is also 81 degrees. So these would be alternate interior angles. So that would also be 81 degrees. Okay, you could also say that this is corresponding to angle 81. So that would be another option that you could use. Okay, number 6. What is the sum of angles 1 and 2? So this isn't just asking for one measure, it's asking us to find the measure and then add them together. So angle 1 is going to be 180 minus 105, and that's going to be 95. So since angle 1 is 95, that is vertical to angle 2. So angle 2 is also 95. So 95 plus 95, that would be the sum of angles 1 and 2. So that would be, let's see, 180 plus 10 would be 190 degrees. And what is the value of x? Now this one's a little bit different. You can see that we have two different transversals here, and that's perfectly okay. We can still use what we know, just using one transversal at a time. So I would start with noticing we want to know what is the value of x. So this is what we need to focus on, is what is this angle measure. Now when I say that angle measure, I'm looking at the angle formed by, if I look at this intersection, it's this angle here. So if I take this intersection and I look at it here, it would be formed by this angle. So that angle that's highlighted is 42 plus something that we don't know to form this angle. Now what we know about this intersection here, even though we have three angles, they still need to add up to be 180 because they form this straight line. So what we can do is find our missing angle here and use that to add it to 42 to find angle x. So let's see what that missing angle is. Well, it's going to be 180 minus 55 minus 42. Another way you could do that is you could add 55 and 42. And 55 plus 42 would be 97. So it's really 180 minus 97. Either way, you're going to get the same answer. So again, just make sure that you check behind yourself in a calculator. 180 minus 97 is going to give us 83. Right, so either way you do that, you would get 83 as that missing angle measure. So I'm going to write that here so that we can keep track. All right, so now we want to find angle x, and again we're going to do that by seeing that angle x corresponds to this angle here. So we need to add together 83 and 42 to find that angle measure. All right, so let's see, 83 and 42 would be 120 plus 5, so 125 would be the measure of x. All right, that is all the different types of questions that you're going to encounter with alternate interior-exterior angles. We also combined some vertical angles, corresponding angles in this one, so this is a good summary of all the different angle relationships we have learned so far.